Microsoft is also getting into the ASIC game, hoping to primarily use its own Maya chips in its Azure data centers. Although little has been revealed since plans were announced in 2023, and its next Maya chip is facing delays. Intel has its own Gaudi line of custom ASICs for AI. Tesla has announced an ASIC, and Qualcomm is breaking into data center chips with the AI200. Of course, there's also a slew of startups going all in on custom AI chips too, like Cerebras, making huge full-wafer AI chips, and Grok, with inference-focused language processing units. The final big category of AI chips are those made for running edge AI, on-device instead of in the cloud.
You might want to be able to run an AI model locally on your personal device, even a smartphone. And so there may be, as part of the processor in that chip, a module that has AI processing capability. So you don't have to have communication all the way back to a data center, and you can preserve privacy of your data on your phone.
An NPU, Neural Processing Unit, is a major edge AI chip, a dedicated AI accelerator that's integrated into a phone or laptop's primary chip, what's called an SoC.
A system on a chip, which is kind of a chip that has like many different modules in it that do different aspects of the computation. Because obviously in a phone, you need to have a very compressed system that is able to do lots of things. And so it's not kind of a separately packaged AI chip.
They take up less silicon and therefore they cost less, often substantially less than a big data center chip would.
NPUs enabling AI in PCs are primarily made by Qualcomm, Intel, and AMD. For MacBooks, Apple's in-house M-series chips include a dedicated neural engine too, although Apple doesn't use the term NPU. Similar neural accelerators, tiny processors dedicated to AI math, are now built into the latest iPhone A-series chips too, which we got to see in September.
Why is on-device AI so important?
We know that when we can do things on device, we are able to manage people's privacy in the best way. The other thing about it is efficient for us, it is responsive. We know that we are much more in control over the experience.
The latest Android phones also have NPUs for AI built into their primary Qualcomm Snapdragon chips, and Samsung has its own NPU on its Galaxy phones too. NPUs also power AI in cars, robots, cameras, smart home devices, and more, made by companies like NXP and NVIDIA.
And so right now, most of the attention, most of the dollars are going towards the data center, but over time that's going to change because we'll have AI deployed in our phones and our cars and on wearables, all sorts of other applications to a much greater degree than today.
Then there's FPGAs, Field Programmable Gate Arrays, which can be used in data centers or embedded on device. These chips can be reconfigured with software after they're made for use in all sorts of applications, like signal processing, networking, and yes, AI. Although far more flexible than NPUs or ASICs, FPGAs have lower raw performance and lower energy efficiency for AI workloads.
You would choose an FPGA because you didn't want to have to design your own ASIC. But if you're going to operate thousands and thousands of them, ASICs are cheaper.
AMD became the largest FPGA maker after acquiring Xilinx for $49 billion in 2022, with Intel in second thanks to its $16.7 billion purchase of Altera in 2015. Now that we've laid out all the types of AI chips and the biggest players designing them all, it's important to talk about where they're actually manufactured. Because the giants like NVIDIA, Google, and Amazon almost all rely on a single company to make them all, Taiwan Semiconductor Manufacturing Company. Saif Khan was an AI and semiconductor policy advisor for the Biden administration.
They were largely manufactured in Taiwan, and so that was kind of a new geopolitical issue in the semiconductor industry.
Fast forward through the CHIPS Act to today, and TSMC has a giant new chip fabrication plant in Arizona, where we got the first on-camera tour in December. Apple has committed to moving some chip production to TSMC Arizona, although its latest iPhone A19 Pro chip is made on TSMC 3nm, currently only possible in Taiwan. NVIDIA's Blackwell, however, is made with TSMC's 4nm node, which means
we are now manufacturing in full production Blackwell in Arizona.
With help from a major investment from the US government, Intel has revived its foundry business and is also making advanced node 18A chips at a new Arizona fab. Fair to say that AI might be bringing the silicon back to Silicon Valley?
That's a great take, yes. It creates an incredible opportunity, not just to manufacture chips here, but actually leverage, physical AI and leverage all these other capabilities that help advance, a lot of the manufacturing that will be coming back here to make sure that the US stays globally competitive.
Huawei, ByteDance, and Alibaba are some major Chinese players making custom ASICs, although they are limited by export controls on the most advanced equipment and AI chips, like NVIDIA's Blackwell. The other big differentiator will be who can secure enough power for all this huge AI data center build-out.
If the US wants to continue to lead in AI, we continue to be fraught with energy risk. China's done that much better than us, for instance, and while we do have the best chips in the world, and I believe so by multiple generations, I believe that our need to build out energy is critical.
But with NVIDIA's lead as the most valuable company in the world, companies are not slowing down in the race to make their own AI chips. Although dethroning NVIDIA won't come easily.
They have that position because they've earned it and they've spent the years building it and they've won that developer ecosystem. But that market's going to get so big that we're going to continue to see new entrants.